Question 14. First of all, with a complex number question, I would always draw an Argand diagram. Don't be a wretch, draw a sketch. As my old maths teacher used to drum into me. So we draw an Argand diagram and try and put them in. This really helps you to get the correct argument because you can see it very clearly. So minus root 6 minus I root 2. So here you've got your real axis, here you've got your imaginary axis. You can see straight away it's going to be a negative argument. And again, approximately for Z2, roughly they're 1 and minus 1. It's just an approximation, but it gives us an idea. So now let's try and write them in the modulus argument form, r cos theta plus I sine theta. So we need to work out first what are the modulus, what are the lengths of each of these complex numbers, what are the magnitudes, what's the size. So the modulus of Z1 is, and let's split it into each bit, root 6 over 2 squared plus minus root 2 over 2 squared. We have there root 8 over 4, which is equal to root 2. And similarly for the modulus of Z2, it's much easier this time. The square root of 1 squared plus minus 1 squared is equal to the square root of 2. Now the arguments of each of these complex numbers. Argument of Z1, if we have a look there, the argument, as you can see, is that angle there. So that's tan to the minus 1 of this thing. So first of all, we do the opposite divided by the adjacent. The opposite is the complex number, so that's root 2 over 2 divided by the adjacent, which is root 6 over 2. Simplifying the 2's, we get tan to the minus 1 of, and root 2 over root 6 is the same as minus root 2 over root 6 is minus 1 over root 3. And the argument, you can use your special triangles for that. You should know that that is, the angle there is pi by 6, and because it's, you can see where it is on the Argand diagram, it's minus pi by 6. If you don't draw the Argand diagram, it's very easy to get the value over here, which would be 5 pi by 6, which is wrong. The argument of Z2, tan to the minus 1 of minus 1 over 1, well that's 45 degrees, which is pi by 4, and again, you can see here it's negative. So Z1, just write it out in the form r cos theta plus I sine theta, or r cis theta, root 2 cos pi minus pi by 6 plus I sine minus pi by 6. Don't forget the whole thing is in brackets. Then Z2 is root 2 cos, scroll down a touch, minus pi by 4 plus I sine pi by 4 minus pi by 4. Now part B. Show that Z1 divided by Z2 is equal to cos pi by 12 plus I sine pi by 12. Now you don't need to, in this case, use the exponential form, but it does help to see where it comes from. If we write it in exponential form, r is root 2 and theta is minus pi by 6, so it's r e to the I theta, so minus pi by 6i, and then Z2 in similar form is root 2 e to the minus pi by 4i. Moving down, Z1 divided by Z2 would then be root 2 e to the minus pi by 6i divided by root e to the minus pi by 4i. Obviously the root 2's cancel. There we go. And we're left with, when you divide two powers, you subtract the indices, and this is a good way for you to remember that when you divide two complex numbers, you subtract the arguments. And it works because of the geometric form is the easiest way to see that. So we get minus pi by 6, take away minus pi by 4 is obviously pi by 6 plus pi by 4. which you can see the simplification there, make it all pi by 12s, which is equal to pi by 12. So the answer is then e to the pi by 12 I, which in the form they ask it for, the r-cis theta form, is e cos pi by 12 plus I sine pi by 12. Now question part C. By the way, you don't need to use this exponential form if you're happy just subtracting the arguments and you understand that, then just do it and save time. It's only 2 marks, so it should be quite an easy question. And now part C. This says find the value of z1 over z2 in the form a plus bi, where a and b are to be determined exactly in radical surd form. And then the second part asks you hence or otherwise find the exact values of cos pi by 12 and sine pi by 12. It's very important where the hence comes in this particular question. The hence comes later on. So we don't use part B immediately, we use part B in the second half of part C. It would be quite handy if it was C part 1 and C part 2, but this one isn't split up that way. But in order to find z1 over z2 in the form a plus bi, we need to use back to the initial values where that z1 and z2 are in that form, the real and imaginary form. So z1 over z2 is equal to z1 in real and imaginary form, root 6 over 2 minus I root 2 over 2, divided by z2, which is 1 minus I. Now, obviously we don't like here this complex numbers on the bottom of a fraction, so we multiply top and bottom by the complex conjugate, 1 plus I. And simplifying, we can take out a factor of a half there from the top. And then we're left with root 6 minus root 2i times 1 plus I on the top, and on the bottom, as you can see, a number multiplied by its conjugate is its modulus squared, so that's just 2. You should be able to do that very quickly. You should get familiar with complex numbers to do that. So then, that's a half times a half is a quarter, so we'll take a quarter out and we'll expand the brackets. We get root 6 plus root 6i minus root 2i minus root 2i squared. Obviously I squared is minus 1, so that becomes plus root 2. So we have root 6 plus root 2, take away, add I sine root 6 minus root 2, all divided by 4. But because we want them in the real part and the imaginary part, this is A and this is B. So therefore this must be equal to cos pi by 12, and this is equal to I sine pi by 12. The real part is cos pi by 12, so cos pi by 12 is equal to root 6 plus root 2 over 4, and sine pi by 12 is equal to root 6 minus root 2 over 4.